Eliminating a dangerous species, impact, responsibility, and future. Mosquitoes, humanity's most dangerous enemy. The natural world operates in a delicate balance, but of the millions of species that exist on Earth, mosquitoes have emerged as a major threat to human health. With more than 3,500 different species, not all mosquitoes are harmful. However, species such as Anopheles, Aedes aegypti, and Culex are responsible for the spread of serious diseases such as malaria, dengue fever, Zika virus disease, and chikungunya. According to the World Health Organization, about 400,000 people die from malaria each year, mostly children under the age of 5 in Africa. Dengue fever is equally dangerous, with more than 100 million cases reported annually, many of which are fatal. These numbers show the devastation that mosquitoes cause to public health. Mosquitoes are not only a health hazard, they also have a serious economic impact. Countries burdened by mosquito-borne diseases often have to devote significant resources to disease control, treatment, and support for victims. This cost reduces resources available for investment in other areas such as education and economic development. Therefore, eliminating mosquitoes is not only a health issue, but also an economic and sustainability issue. Should mosquitoes be eliminated? The idea of eliminating a species from an ecosystem may seem extreme, but there has been serious scientific discussion about it. Some scientists argue that eliminating mosquitoes, especially those that transmit disease, could have benefits that far outweigh the potential risks. Their argument is based on a few key reasons. Public health: eliminating mosquitoes could prevent millions of deaths and illnesses each year. This is a huge step forward in improving the quality of life, especially in poor areas where mosquito-borne diseases are rampant. Reduced economic burden: without having to deal with mosquito-borne diseases, countries can reallocate resources to other areas such as education, infrastructure, and social development. Advancing modern technologies such as genetic modification have opened up the opportunity to eliminate disease-carrying mosquitoes without causing major impacts on other species. For example, gene-drive technology can reduce mosquito populations by interfering with their ability to reproduce. Gene technology and the promise of a mosquito-free future. Mosquitoes, tiny but deadly insects, are the primary vectors of many dangerous infectious diseases such as malaria, dengue fever, Zika virus, and chikungunya. According to the World Health Organization, malaria kills more than 600,000 people each year, while dengue continues to affect millions worldwide. For decades, humans have sought to control mosquito populations through measures such as pesticides, mosquito nets, vaccine development, and even fish that feed on mosquito larvae. However, these solutions have only been temporary and have never solved the problem. With the advancement of biotechnology, a new potential method has emerged: using gene editing technology to reduce or even completely eliminate disease-carrying mosquito populations. Among them, a prominent concept called gene drives is attracting the attention of scientists around the world. By harnessing the power of advanced gene editing tools such as CRISPR-Cas9, gene drives could open up a new direction that is promising, but also fraught with ethical and safety challenges. What is a gene drive and how does it work? A gene drive is a biological mechanism that allows a mutated gene to be passed on to the next generation at a higher rate than naturally occurring. In natural populations, a gene typically has a 50% chance of being passed on to its offspring. However, gene drives change this rule by inserting mutated genes into mosquito DNA, increasing the chance of passing on a mutated gene to 95% or even higher. When applied to mosquitoes, gene drives can be designed to accomplish a variety of goals. One common approach is to make mosquitoes sterile, which would lead to a decline in their numbers over time. Another is to create genes that make mosquitoes incapable of transmitting disease, such as making them incapable of harboring the malaria parasite. Early experiments have shown surprising results. In the laboratory, researchers have successfully reduced the number of Anopheles gambiae, the main mosquito species that transmits malaria, to near extinction in controlled populations. These results offer great hope for the possibility of eliminating dangerous infectious diseases on a global scale. Potential benefits of gene drives: Eliminate dangerous diseases. Gene drives offer the opportunity to eradicate or control disease-carrying mosquitoes in a cost-effective and sustainable manner. By reducing or eliminating disease-carrying mosquitoes, cases of malaria, dengue fever, and other mosquito-borne diseases could be dramatically reduced, saving millions of lives each year. Reduce pesticide use. Current pesticide use not only negatively impacts the environment, but also leads to resistance in mosquitoes. Gene drives offer a biological alternative that does not rely on toxic chemicals. Long-term effects. Once a gene drive is released into the wild, the mutant genes will spread through the mosquito population without further intervention, providing a sustainable effect over time. Ecological impacts and ethical choices. One of the biggest concerns about mosquito elimination is the potential for disruption to ecosystems. Mosquitoes are a food source for many other species, including fish, birds, and predatory insects. However, research shows that only a few species of mosquitoes are important in the food chain, and predators can often adapt by finding other food sources. From an ethical perspective, the question becomes more complicated. Do we have the right to intervene in nature to eliminate a species? Supporters argue that we have a responsibility to save the lives of millions of people and improve their quality of life. Opponents, on the other hand, worry that these changes could have unintended consequences, affecting the natural balance that we do not yet fully understand. Successes and failures, lessons from early applications. Suppose we overcome the ethical hurdles and begin using gene drives. An international committee is established to oversee and coordinate the project. After years of testing, tens of thousands of genetically modified mosquitoes are released into the wild in Africa. The result was a dramatic reduction in the population of disease-carrying mosquitoes, leading to a significant reduction in malaria cases. This success excited the scientific community and regulators, who expanded the application to other areas, including agricultural pest and invasive species control. However, not all has been smooth sailing. A notable example is the Hawaiian invasive gecko control project to protect native snails. Initially, the gene drive worked well, but then spread beyond expectations through the pet trade, leading to a global decline in native geckos. This incident led the committee to stop using the gene drive for invasive species control projects. Final considerations: our responsibilities. When faced with issues like eliminating mosquitoes or controlling invasive species, the question is not whether we can do it. Rather, the focus is on how we should do it, with the goal of serving not only the interests of humans, but also protecting the global ecosystem. The natural world exists on a delicate balance. In the ecological chain, even pests like mosquitoes play a role. Mosquitoes are not only vectors of disease, but also important food sources for many other species such as birds, fish, and bats. The complete elimination of one species can have unintended consequences, disrupting ecosystems that are already under pressure from human activities. However, it is undeniable that, over the years, mosquitoes have caused millions of deaths each year through diseases such as malaria, dengue fever, and Zika. This is a serious humanitarian problem that demands a solution. But it cannot be solved simply by technology or hasty steps. We must consider carefully, can human intervention in nature bring sustainable results? A future for all. In our evolutionary journey, humans have made great strides thanks to their ability to adapt and innovate. But with great power comes great responsibility. Weighing human interests against the interests of the ecosystem is not an easy task, but it is essential to ensure the long-term survival of the planet. Perhaps instead of focusing on elimination, we should aim for sustainable and innovative control. Technology can be used to minimize the negative impacts of mosquitoes without causing serious consequences for the ecosystem. For example, we could research vaccines or less invasive biological control methods instead of eradicating a species. Ultimately, the answer is not whether we can do it, but how we should do it. Our responsibility is not just to ourselves, but to all other creatures on this planet. Every decision we make today will shape the future of Earth, our shared home. We have the power to build a better future. It is up to us whether we choose to do it responsibly.